ultimately, our team is completely focused on this design automation standpoint. We can create all of the geometries that you do in traditional CAD, but in a way that is completely robust for new incoming patients and adaptable. Okay, so here's an implementation. It shows the reform software from Radii bringing in a new scan, getting the recommendation of fit. They do some cleanup of the scan. They get all their adjustments in to kind of understand the axis that's important for the geometry that goes on the bottom. And then what you'll see at the end of this is that our team built a design automation that is basically a one button click socket. After you've done all this, you just say make socket, and you don't really have to worry about any of that. There might be in the future some choice points about what kind of connection you want at the bottom, maybe some variables to play with. But essentially, we wrote a script leveraging Houdini that in the back end on a server just computes a custom socket based on the input surface that Radii outputs. So we kind of pick up the baton, run a few laps in the background, and then deliver it back to the clinician to where they could then order it from one of our service bureaus, or if they happen to have printers themselves, access to them if they're internal to a company like that. So here all of those rectifications are happening, all the important stuff of a good socket fit, and then it basically, once you have the trim lines and everything, it's just send it for processing, and out the other end, you get this final socket. This is a very simple 3D printed socket, but it has all of the hardware and all of the considerations to be robust. Here we're showing kind of like what could be in the future as we develop, more of the potential of the 3D printed context. This was more of a show car piece, just to get clinicians thinking about what's possible.